Today, I will talk about localization of brain activity with MEG. We will use MEG processor to localize brain activity. We will launch source localization window. Once you launch the MEG processor, you're looking for menu source, and there are initial-line methods can be used to localize brain activity. For demonstration purpose, we use the first one, which is called MEG Source Imaging. This method basically uses the amplitude of waveform to scan sources. Once you click the menu, it will launch the window. For example, this is the MEG processor. If you are not familiar with MEG processor, you can look into the video about MEG processor. As we mentioned, looking for the menu and found the source. As you can see, there are many methods. We use the first one. As you can see, once you launch the MEG processor, you can see there are many parameters. Those parameters can be grouped into 4 groups. Specifically, the 4 groups of parameters are data selection, price localization data processor, and storing trial. The third one is spatial region of interest. For example, scan the entire brain head or just part of the brain, and then they scan algorithms. Typically, we select the kernel trial and exclude the bad channel or select the good channel, and then we select the time window we are interested in. It's called an active window. For example, here we select this time window, click Get Active. Then this is the waveform we are interested in. Following that is the data processor for localization. We can do additional filter, we can fix the trigger shift, we can even find a control window with a background activity. For multiple trial scan, we will need to select the trial for store the sources. In this demonstration, we just use the current trial, so it's a single trial, so we don't need to select this one. After we select the data, define the pre-localization processor, we define the scan region, we call it region of interest. Typically, we use the default parameters, which basically scan the entire brain. The unit is millimeter. As you can see, X is from left to right, Y is from inferior to superior, Z means frontal to back. Basically, this is the typical size of the brain. The right side is some parameters. Step size means the size of step. The large number means low resolution and the faster scan. Source slices. For real-time source localization, this is equal to the length of the data. And we can also define this scan algorithm. For example, for functional mapping, we typically use real time because the time window is short. For localized epileptic foci, which typically a very long time window, even several hours, we use accumulation. For accumulation, we define the accumulated slices, which of course is typically much smaller than the time window. Once you define the scan type, find the accumulated slices, and we check the algorithm. We typically use the default algorithm. Once you get all those parameters, click Start. And then the program will show you the information. For example, this shows you they are prepared for imaging function, no activity. Here means how many segments. This is a voxel. We go through all slices and all voxels. And once we click Start, and you just wait.